First, I will present a text-supervised normalization system, which we created in Cultura. And then I will present modifications that we apply to this supervised text normalization system in order to obtain unsupervised normalization. And finally, I will show experimental results and ideas for future improvement. Actually, the word May with E has 34 occurrences in the 6041 depositions. 6041 depositions represent a collection of around 8,000 documents from 17th century. And the documents in this collection describe atrocities and other events that happened in 17th century during the Irish rebellions. And this collection was manually digitized by Trinity College from Dublin. And actually this was one of the collections that we normalized in the Cultura project. The task of Sofia University in the Cultura project was to develop a system for automatically normalizing of historical text documents. So, professional historians who want to explore the Irish rebellion are very interested in the 6041 depositions. However, the general public will prefer normalized versions of these documents. And the other advantage of normalized versions of documents is that once you have the documents normalized, you can directly apply existing tools for example, for information extraction or information retrieval, which are designed for modern language. So, first I will present the supervised text normalization system. It is based on manually created ground truth. To normalize the 6041 depositions, we used a manually created ground truth of 500 documents. So we read each document word by word, and we manually normalized each word that had to be normalized. And it turned out that on average, approximately each fourth word had to be normalized. And this task was really very time consuming. It costed us 15 person-months. And still, there are many collections of historical documents which are digitized, but for which such a ground truth does not exist. And this is another motivation to develop unsupervised text normalization system, which does not rely on such manually created ground truth. However, the system that we created in Cultura is similar to a statistical machine translation system which combines translation model with the language model. There are some principal differences between machine translation and normalization of historical text. In machine translation, the word order cannot be preserved, and permutations of words have to be included in the system. While the challenge in normalization of historical text documents is that one and the same word may have too many different spellings, even in one and the same document. In 6041 deposition especially, there are some documents in which the technical writer, the person that wrote the document, didn't know how to write a particular word, and that is why he wrote it 3 or 4 times in several different ways. And this requires a special translation model that can cope with the high spelling variety in historical language. And in the Cultura project, we created such a model. We call it Rebels. So it automatically extracts spelling variations of subwords, and based on these spelling variations of subwords, the Rebels translation model generates relevant normalization candidates for words in historical spelling. And each normalization candidate is associated with a spelling probability. How it works? From the training corpus, we extract pairs. Each pair consists of historical word in historical spelling, and its modern equivalent. So we take all historical words and we build a deterministic structure of all historical subwords. So actually this deterministic structure represents a finite automaton whose language is all historical subwords. And here we use the algorithm of Bloomer and Bloomer, which builds this structure for linear time. And the size of the structure is also linear in size of all words. And in this deterministic structure, each historical word, has a natural decomposition of subwords. And we do the same thing, so we built another deterministic structure for the modern subwords. So we have hierarchical decomposition of each historic word and its modern equivalent. And then for each training pair, we find a mapping between these decompositions. And this mapping is based on edit distance on trees. And from these mappings, we collect statistic which says how often a particular historical subword is translated as a particular modern subword. And based on these statistics, Rebels generates relevant normalization candidates for unseen historical words which are not presented in the ground truth. To normalize a text in historical spelling, we process word by word. For each word, we call the Rebels translation model, and from the normalization candidates, we build a search graph. And each path in this graph represents one possible normalization of the input historical text. Most of the paths make no sense because the Rebels translation model does not take into account word context. And that is why we combine the spelling probabilities provided by the Rebels translation model with probabilities that come from standard statistical language model. In fact, we use a big RAM language model here. And the combination of these two kinds of probabilities, we call it relevance score. So here we use a standard walk linear, maximum entropy walk linear model. And the coefficients in these combinations, CTM and COM, they show how much we trust the corresponding probabilities. So the problem that arises here is how to find these trust coefficients. Actually, we optimize the likelihood of the ground truth, and so we find the coefficients that optimize the likelihood of the ground truth. And to do this, in Cultura, we developed a special framework which makes the realization of such statistical optimization problems very easy. So we call it the framework of functional automata. A functional automata represents a graph in which the transitions are labeled with functions. And when we follow a path from the initial state to a final state, we have to multiply the corresponding functions. And the function represented by a functional automata represents just the sum of all paths. And it turns out that the likelihood can be represented with such functional automata. And what makes the optimization of the likelihood very easy is that once we have a functional automata, we can automatically construct functional automaton for the partial derivative. And in this way, we can use some gradient method to optimize the likelihood. So what we have so far is this architecture. So we have the Rebels translation model, which is trained on manually created ground truth. We have a training module, which is based on functional automata. A search module, which is again based on functional automaton. Actually, the search module selects the path with the highest relevance score in the search graph. Okay, now I will show how we modified this picture to obtain an unsupervised text normalization system. So we replaced the manually created ground truth with a module for unsupervised generation of training pairs. And so far we do not have a training module. So how do we generate the training pairs in this way? We use similarity search. So for each, what we do is that for each historical word, we first check if it is presented in a list of modern words. If it is there, then we assume that the historical word has not changed its spelling. However, if the historical word is not presented in a list of modern words, then we extract from the list of modern words all modern words which are at Levenstein distance 1 from the historical word. If we do not find such modern words, then we continue with distance 2 and with distance 3. So the idea here is that in this way we hope that we will find the modern word that corresponds to the historical one. However, of course, in this way we will generate many other modern words which are not the right translation of the historical one. Or in other words, in this way we introduce noise in the model. And to reduce this noise, we use a threshold. So if we generate too many modern words, then we do not use the training pairs we do not use the corresponding pairs for training of the Rebels model. Now I would like to present experimental results. So here we see on the first line, the first column represents just the method. The second column represents whether we use unsupervised generated training pairs or we use the supervised. Actually, only the last one use supervised generated pairs. The third column represents whether we use the spelling probabilities when we select the best path in the search graph. The fourth column represents whether we use the language model. And the last two columns, they represent accuracy in blue. So actually the first line is a baseline. So it shows what happens if we do not normalize the text at all. So as I said at the beginning, approximately each fourth word has to be normalized, and here we see this, exactly this. This means that the accuracy is 75% approximately. Line number 2 shows what happens if we use unsupervised generation of training pairs, but we use only the language model to find the best path in the search graph. Here we do not use the spelling probabilities from the Rebel's translation model. And in this way we see that the accuracy goes down to 68% approximately. So this means that in this way we cannot normalize the text. We have to use the spelling probabilities. Line 3 shows what happens if we use only the spelling probabilities, but we do not use the statistical language model. Then we achieve improvement to 78%. Line number 4 represents what happens if we use both the spelling probabilities and the language model. So far we do not have a training module, and that is why here we adjust the truth coefficients of the walk linear model in a way that the spelling probabilities and the language model have equal influence on the path in the search graph. And we see that in this way, so this is purely unsupervised system, the accuracy is 82% approximately. Line number 5 represents a semi-supervised system. So we have unsupervised training pairs, but we use the manually created ground truth to find the coefficients, the truth coefficients. And we see that this leads to improvement to 85%, almost 85%. And the last one is, it represents purely supervised system. Actually, this is the system that we created in the Cultura project. So we use manually created ground truth for everything, and the accuracy is 84% approximately. So if somebody is interested in this purely supervised system, we can make a small demo. We can make a small demo after the presentation. So this system is available on the web, and there is a web graphical interface, and it can be tested. We have some ideas how to improve the unsupervised system in the future. So first we have to add a training module, and it can be based on maximum a posteriori probabilities, for example. And we can improve the unsupervised generation of the training pairs. So here we have the idea to use hidden Markov model in which the states are the modern words, and each state emits historical words. And we can train this module on the texts, and in this way the training pairs will come with probabilities, and we hope that we will reduce the noise that the similarity search generates. Thank you.
Thank you for your very interesting talk. I have two small questions, actually, concerning your ground truth. So the results presented here, I don't think you said on what part of the ground truth this was measured? How big was your test set here? So you have this ground truth of 200,000 words. How much of that did you use to test on in these? So you had training sets and you had a test set.
So we use 90% of the documents for training and 10% on the documents the other 10% for test.
Okay.
But we have tenfold cross validation. So
okay.
we have 10 cases in which these 10% vary.
Okay, so these results are 10 times the average of 10 grams. Okay, thank you. Now the ground truth you build is a marvelous resource. I would be very interested in that. Do you make it available?
The ground truth, you mean the 500 manually normalized documents. So, so far we have not made it available, but we have to contact Trinity College from Dublin because actually they have the rights on these documents. And if you are interested in this, we can
yes, I'll
communicate after the presentation.
Okay, thank you.
Thank you very much. As I missed the beginning, if I ask you the wrong question, excuse me. And so your objective is to make a normalized text. And for where is the place of the real transcription of diplomatic and transcription of the historical text? There are always some differences, it's right?
So, I'm sorry if I have not understood correctly your question, but the answer is that we have a demo on the web and you can play with it and you can see how it works. And there in this demo you can see, you can enter text in early modern English and you can click a button and you can see the normalized version of the text. So if you are interested in this, we can show it.
I have just a little question as to your language model. For training the language model, these texts were normalized you used there, or were these texts with historic orthography?
So we used the Gutenberg English corpus of modern English. So it's for modern English language.
Okay, for modern.
So we take many documents from the Gutenberg corpus and we trained this big RAM model.
Yeah, I was wondering, so this seems to have some great applications, for example, for searching or indexing these historical words. On the other hand, I'm thinking of, for example, uses in a scholarly environment where the people are actually very much interested to keep those original historical spelling. I was wondering if you developed this system with a particular application scenario in mind.
So one of the tasks in Cultura project was to use these normalized documents for information retrieval and information extraction. And in this project, the other partners created a search engine which is based on the normalized documents. So, and you can search, so you can type a word in modern spelling and you can see both, so in this way, you're not obliged to know the historical spelling. I'm not sure that I answered your question.
Excuse me, I try to ask you in a different manner. So, your point of depart, you have uncontrolled transcription, OCR transcription. Is it right?
So, our system works on digitized text. So
digitized
yeah.
image.
No, so no. The documents are. I mean that we do not work with images, but directly with the text. So, for example, one way to use the system is first to run
output of the OCR.
OCR,
yes.
And the OCR will produce text in historical spelling, and then you can apply this system.
All right. And then you have the normalized text with your dictionary of modern English.
Sorry?
You modernize with your model and in modern English, in a sense.
Yeah, the result,
Yes,
the output is
so.
modern
What I wanted to ask you, we have exactly the same problem with French 16th century text, and for your ground truths, I think it must be the transcription controlled manually.
Yes.
So you, with your tool, we have normalized text, but we don't know what is exactly the state of text in historical documents. Is it right?
Sorry, I didn't get it. But
yes, it's probably another level of a problem you don't manage. But I think it's important to have this point of depart, the ground truth. You have sometimes it is controlled by the specialist and by the philolog.
Yes.
Yes, and so it's a question I want you to. From the point of view of humanity scholars, we want it to control. We want to establish the historical text with historical spelling.
Is your question if there's a link between the corrected normalized spelled word and the historical form in which it was spelled? Is that true?
Yeah. If this is the question, in the ground truth, it represents exactly this. So the ground truth represents a document in which you have the historical word and you have its modern equivalent, which was produced manually by a human. This is the supervised system. In the unsupervised system, you do not have this ground truth. You have automatically created ground truth.
Okay. Ashur? Okay. Of course, your proposal deals with printed texts. But my question about pre-printing, I mean the text of manuscripts in Arabic as example. Did we have any solution for these texts which written by hand before printing? Is there any solution?
Sorry, but I didn't understand the question, but I think that...
Again, in Arabic, we have a many of historical texts, okay?
Yeah.
Then your proposal can deal with these texts before printing.
So, if you have images, then first you may apply OCR to obtain historical text, and then you can use this system to normalize the text. But I'm not sure that if this answers your questions.
So can I? Can I? Actually, it's two small questions. One of them is, you speak about orthography. However, do you consider that the farther you go to the past, the orthographic variation may be actually sound variation? It reflects the pronunciation, especially considering languages like English, which is spoken on a large territory with lots of dialects. And if you go, you did not go to Old English period, but if you go there, so the variation is extreme, but it's not a spelling variation, or it's only partly spelling variation. That's one question. And the other question is, many English words preserved the variation until today, like jail, for example, which you can spell J-A-I-L or G-A-O-L. Did you normalize that?
So I will try to answer directly on to your first question. So the idea of the Rebus translation model was exactly to cope with the high spelling variety. So it works on subwords. We find automatically spelling variations of subwords, and in this way we can cope with the high spelling variations. And on the other question, so if there is some concrete typical pattern, typical spelling pattern, because here we use statistics, so this pattern will be found by the Rebus translation model, and it will have high probability. So in this way, it is not required to know the typical patterns a priori, but Rebus will find these patterns automatically.
Yes, I think text normalization is very helpful for the end user and makes really sense for searching. But my question is, how did you deal with abbreviations? In historical documents, abbreviations are very frequent and are often represented by specific characters no longer available in the modern character set.
Yeah, so I think I know what you mean. For example, in the 6041 depositions, you may find THO 2 dots, which means Thomas most of the time. So we have no problem with such situations, because if in the ground truth you can specify that THO 2 dots have to be translated as Thomas. And the translation model, the Rebus translation model, will take this into account. But of course, if you do not have this in the ground truth, then the Rebus translation model will not be able to cope this. So everything depends on the ground truth.
So let's leave it with that for this question. Thank you very, very much.
Thank you.